Hello friends, in this session we will talk about the subject thermodynamics, the very basic subject of your mechanical engineering, or if we precisely say, this is the basic subject of your thermal engineering portion. As we know, there are two exams, that is your engineering services and your gate. So in engineering services, thermodynamics is a part of your paper 1. So in paper 1, that is a thermal portion, the various subjects are your thermodynamics, refrigeration and air conditioning, heat transfer, fluid mechanics, power plant and internal combustion engine. So thermodynamics is the basic part, basic subject of this thermal engineering portion, and this is the most important subject to understand the concept of various other subjects. So thermodynamics is a very important subject for your gate also. Around 2 to 3 marks questions are always asked from the thermodynamics, and this is a highly scoring subject of your gate and your engineering services. If I am telling you about the syllabus of your thermodynamics, both for your engineering services and gate, we will start first with the introduction part of your thermodynamics, various terms included in your thermodynamics and all. Second, we will talk about the zeroth law of thermodynamics, and the concept of temperature, thermometer, etc. Next chapter would be your heat and work interactions. Heat and work interactions. In heat and work interaction, we will talk about the heat transfer and work transfer in various processes like your isothermal process, adiabatic process, your constant pressure process, constant volume process, polytropic process, and so on. So in this we will talk about the work done in closed system, work done in open system, and so on. Next would be our first law of thermodynamics. First law of thermodynamics. In this we will study about the first law of thermodynamics for your closed system, first law of thermodynamics for your open system, steady flow energy equation and unsteady flow energy equation. The next would be your second law of thermodynamics. In second law of thermodynamics, we will deal with the various definitions of second law, that is the Kelvin-Planck statement, your Clausius statement. Also, we will study about the Clausius inequality and the concept of your heat pump, heat engine, refrigerator, how they work, how they follow the Clausius statement, or your PMM2 and PMM3. We will discuss in your second law of thermodynamics. And the continuation of second law of thermodynamics, we will take it to the next chapter, that is your entropy. Entropy is the most important chapter of your thermodynamics, and there is always a question from this chapter, entropy. In this we will discuss about the entropy change of a system for a reversible process, for an irreversible process, entropy change of universe, entropy generation, and so on. The next topic would be your available energy. Next chapter we will study about is your available energy and unavailable energy. That means in this chapter we will study about the various the maximum work that we can obtain from a system, from a closed system, from an open system. What are the irreversibility associated with any heat transfer or any work transfer, and here we will also study about your Gauss-Todela theorem and so on. The next chapter would be your properties of pure substance. Properties of pure substance. In introduction part, we will discuss about what is a pure substances, and in continuation with this discussion, we will take it to the chapter that is your properties of pure substance. In this, we will study about various phase diagrams like your PV diagrams, TS diagrams, your Mollier diagrams, and the properties associated with it. So, the next chapter would be your properties of ideal gas. Properties of ideal gas. In this chapter, we will study about what is an ideal gas, what are the various conditions for a gas to behave like an ideal gas, deviations from an ideal gas, properties of real gas, and various conditions of an ideal gas we will discuss in this chapter. And our last chapter would be your thermodynamic relations. Thermodynamic relations. In thermodynamic relations chapter, we will study about the mathematical terms of your thermodynamics, like your TdS equations, energy equations, your Joule-Thomson coefficient, Clausius-Clapeyron equation, and so on. This chapter is basically a mathematical chapter, kind of nothing more than your conceptual chapter. This is a mathematical chapter of your thermodynamics. So this will be my whole syllabus for your engineering services and for your GATE. So if I would start with the introduction part, so that first we will learn about some basic concepts of thermodynamics. Basic concepts of thermodynamics. So before going to some basic concepts of thermodynamics, first of all, we have to know that what is this subject belongs to. Means what is the meaning of this thermodynamics. What we will going to learn in this chapter. So thermodynamics is a science of energy transfer. Thermodynamics is a science of your energy transfer and its effect on properties of a system. This is the meaning of your thermodynamics. It is a science of energy transfer and its effect on properties of your system. So thermodynamics is a science of energy transfer. Energy is of two kinds, we know, that is heat energy and work energy. So in thermodynamics we will discuss about your heat transfer, energy transfer, and because of these energy transfer, what will be the effect on your properties of a system, what are the various properties of a system changes because of this heat transfer, because of this work transfer. We will all study about this in your thermodynamics. And the main aim of the thermodynamics, if I will talk about the aim of thermodynamics chapter is to convert disorganized form of energy disorganized form of energy means, we will study it later, that what is the meaning of disorganized form of energy or low grade form of energy, which is known as your heat. We will study about that heat is a form of disorganized energy. So aim is to convert disorganized form of energy, that is heat, into organized form of energy. This is the basic aim of my chapter thermodynamics. So if I will go to some basic terms of thermodynamics, first of all, my basic term of thermodynamics is what is the meaning of system. What is the meaning of system? If I would say that system is a reason in space upon which the study is focused. Means this is that reason in your system, is that reason of your space in which you have to study the various properties of the system, what are the changes occurred in the system because of some heat transfer, some of work transfer. So that space on which you focused while during experiment, that space is known as system. The next definition would be, the next term we will discuss is your surrounding. Second one is your surrounding. Surrounding is, if we will talk about that, system is that space on which my concentration is occurred during my experiment, during my study. Surrounding is a region in the space. Surrounding is a region in the space which is external to the system. External to the system. First of all, while during experiment, we will define what is my system, and anything which is external to that system is your surrounding. So surrounding is your anything which is your external to the system. Please note that anything which is external to the system is your surrounding. So the system may be defined as your open system or closed system. We will discuss it later. But when we define a system, a region in a space, anything which is external to that region is my surrounding. So that system would be of three types. One is your closed system, one is your open system, and the last one is your insulated system. We will discuss it up in later. The next definition would be the boundary. The next definition is of boundary. Third one is boundary. Boundary is that reason, or that boundary means boundary is the separation between system and surrounding. That layer or that membrane which will separate your system and surrounding is known as your boundary. Anything which separate your system and your surrounding, that thin layer or that membrane or that boundary is known as the boundary of the system. So if I would talk about the various properties of the boundary of the system, so we will say that your boundary may be rigid. Your boundary may be, this boundary may be rigid. Rigid means it will not move. It may be flexible. Flexible means it will move during the experiment. It may be real. It will actually present in the system, or it may be imaginary. There are four types of boundary. One type is your rigid boundary. That means it will not move. Second type is your flexible boundary, which means during the experiment the boundary will move in the direction of process. Third one is your real boundary, which is actually present in the system, which we can see through our eyes that boundary exists, is known as your real boundary. And the last one is your imaginary boundary, which we will draw while our experiment because of the non-existence of a real boundary. So if we will talk about how a boundary may be rigid. So if I consider a piston cylinder arrangement, if I would consider a piston cylinder arrangement, suppose this is my cylinder, this is a cylinder, and in this is a piston. This is a piston cylinder arrangement. Inside it there is some gases present at some pressure and some volume. Suppose if I have to define the system over here, if I have to define, if my process is working and I have to define my system, I would say that this part of the piston cylinder arrangement, this dotted part is my system. Means my whole concentration during the experiment is focused on this dotted part. Only in this area my focus should be concentrated. So I would say that this is my system. This is my system, and external to this dotted area is my surrounding. External to this is my surrounding. External to this is surrounding. So if we talk about the system and the surrounding, the layers which will differentiate between your system and surrounding is known as your boundary. So in this system there are four boundaries. One is this dotted line, above dotted line, one is this dotted line, next one is on this and this dotted line. If I would say that these boundaries, this one, and this one, these three boundaries are your rigid boundaries, which means it will not move during your experiment. When your piston is moving, these three boundaries will not move in any case. So these are the rigid boundaries present in the system. And if I would talk about this boundary, which is coinciding with the piston wall, so when this piston moves, this boundary will also move. So this is a type of your flexible boundary. So this is a type of your flexible boundary. This will move when your piston moves during the process. If compression occurs, your volume decreases, piston moves in towards the left. If your process occurs is expansion process, that means your piston moves towards right. So that boundary, this wall will move along with the process. So this is known as your flexible boundary. If we will talk about what is the meaning of real and imaginary boundary. So if we will talk about the real and imaginary boundary, if I am considering again this piston cylinder arrangement. Suppose this is a piston cylinder arrangement. I am again considering the same arrangement, your piston cylinder arrangement. And as earlier, we will say that if we have to define the system, we will define that this dotted part is my system. This dotted part is my system. This is my system. And hence, we already know that in this system we have your four boundaries are present here, but all the boundaries are this boundary, this one boundary, this dotted line and this dotted line. All of them are real boundaries. Real boundaries means all of them are actually present in the system. We can see them through our eyes. So this is known as your real boundaries. And if we are talking about what is the meaning of your imaginary boundary, if we are talking about what is the meaning of imaginary boundary, suppose I am considering a pipe. Suppose I am considering a nozzle. This is my nozzle in which a fluid flows from this direction to this direction. Fluid will flow through this nozzle, this converging nozzle. Suppose in this case, when a flow occurs, this is a case of open system, we will discuss it later. Suppose in this case, I have to define my system. I would say that in this case, this dotted part is my system. My consideration is only on this dotted part. I am much more interested in the properties of system which is inside this dotted portion. This is known as my system. I defined my system through this type of boundaries, and I am saying that this portion which is inside the dotted system is my which is inside the dotted part is my your system. Next, if I would go through the types of boundary here, in this case these two boundaries which are actually present in the system are known as your real boundaries. These are known as your real boundaries because these are actually present in the system. And if we have to talk about the other two boundaries, which one boundaries? These two boundaries, this boundary and this boundary, which is not exactly present in the system. I am only virtually draw these two lines to define my system. If I will not draw these two lines in the space, I will never ever define my system. So to define the system, I have to draw these two lines. So these are known as your imaginary boundaries. imaginary boundaries because these are not actually present in the system. These are my imaginary boundaries. So the boundaries would be of two types. One we will see here. One is your rigid boundaries and flexible boundary. Rigid boundary means that will not move during the process. Flexible boundary means that will move during the process. Next is your real boundaries, which means these are actually present in the system, and the another one is your imaginary boundaries, which we will draw so that we can make our system more or less defined. Also, we will say here that your system and surrounding comprises of your universe. If I would note that one thing here, if I would say that one thing I will study about my system, external to that system, anything external to that system is my surrounding. And if I combine my system and surrounding, this will cover my whole universe. This will cover my whole universe. You have to note this point, that the reason on which your study is focused, that is your system, anything external to that reason is your surrounding, and the combination of system and surrounding is known as your universe. So universe is system plus surrounding. Next, if I will talk about your types of system. Next, our topic is your types of system. There are three types of systems. Types of system. As I earlier told you, there are three types of system. One type is your closed system. First one is your closed system. As the name suggests, what is the meaning of closed system is, as our name suggests of this system, that closed system means there is no mass transfer. There is no mass transfer. Only energy can transfer in the system. Only energy can transfer. Which means in the system there would be no mass transfer. Mass would never enter in the system, nor it will leave from the system. Only your energy is of two types. Only heat or work can enter to the system, or heat or work can go out of the system, but mass will never ever leave from the system or entering into the system. If we will say accordingly that what is the examples of closed system, if I will talk about the examples of closed system, example of closed system is your piston cylinder arrangement, as which we will study earlier, piston cylinder arrangement. So this piston cylinder arrangement, which is not having any valve, without having any valve, without having valves, are your closed system. So closed system are those in which there would be no mass transfer. Next is, if I would precisely say, if I would take it in another definition, in closed system you have to note one thing. Most important point, you have to note one thing. There would be no change in mass of the system. Mass of the system would not change in your closed system. Mass of the system would not change, and also this is the most important, also identity of the mass would not change. Identity of the mass would not change. What is the meaning of this line, identity of mass would not change? So if I have to explain this, what is the meaning of this, identity of mass would not change? Let us suppose that this is a system. This is my any system which I will define it. So I draw the boundaries to define my system. I say that this dotted line, the area under this dotted line is my system. This is my system. And I say that from here there is a some mass flow rate. Let us suppose the mass flow rate is m dot 1. This is your inlet section and this is your outlet section. There is a mass flow rate from inlet section, that is your m dot 1, and from here there is a mass flow rate, suppose this is m dot 2. And if I say that your mass flow rate m dot 1 is equal to your mass flow rate m dot 2, if the mass entering is equal to your mass leaving the system, it means mass of control volume is constant. Or you can say that mass of your system is constant. So in this case, this is not a type of closed system, because in this case your identity of mass in the system changes. In this, identity changes, and if identity changes, this implies that it is not a closed system. It is not a closed system. What it means, the change of identity, if I would say that from here, suppose a particle enters, it will have some energy. We will discuss when a particle enters in a system of thermodynamics, it will have four types of energy. One is its internal energy, second one is its flow energy, third one is its kinetic energy, and fourth one is its potential energy. So when this m dot 1 enters in the system, it will have some kind of energy, some kind of identity it belongs with. When it leaves from here, it will have another kind of energy, another kind of identity, because its identity changes. So when the mass enters, it will have another identity, and when it leaves, its identity change. If I would correlate it with your classroom, suppose in our classroom there are 100 number of students. At one instant, one student enters and another student leaves. Suppose in that room one student enters and another student leaves. It means that the system mass, the mass of that classroom will not change, because one will leave and one will enter. But the identity of that person who is leaving is different from the identity of that person who is entering. Identity of the mass changes. It means that that system is not your closed system, that is your open system. In closed system there would be no change in identity of the mass that is going out or going in the system. Next one is your second type of your system is your open system. Second type is my open system. Open system means the both energy and mass can transfer. Both energy transfer and mass transfer takes place in the system. It means in system your mass can also transfer, mass can also enter into the system, also leaving from the system, and also your energy, that is your work and heat, also energy transfer can takes place in the system. This is known as your open system. Open system have both energy and mass transfer, which is your taking place in the system. If I will talk about the example of this open system example is we will know that there is a device known as your turbines, pumps, compressors, etc. So turbine, pumps, compressor, in which there is mass transfer and energy transfer, both will take place simultaneously. It is known as your open system. If I have to define an open system, suppose this is a duct in which flow occurs. And if I define the system, I would say that this is my system which I will be talking about. This dotted line, the area under this dotted line is my system. So in open system, we have to define a system with the help of your imaginary boundaries and with the help of rigid boundaries. And in this system, there is your mass transfer. Mass can enter, mass can leave. There is energy transfer also, means heat can enter to the system, heat can leave from the system. Work should be done by the system, or we will do some work on the system. Also, work can be transferred, heat can be transferred, and also your mass transfer will take place. So in this case, in open system, this volume on which our study is focused, the volume on which our study is focused is known as your control volume. This volume on which my study is focused is known as your control volume. Control volume is that region in the space, in case of your open system, on which my whole analysis should be focused, and this is known as your control volume. Third type of my system is your insulated or isolated system. Third one is my isolated system. Third kind of system is isolated system. An isolated system is that system in which no mass transfer and no energy transfer, no mass transfer and no energy transfer takes place. It is that system in which there would be no mass transfer and no energy transfer takes place. If I would say about the examples of your insulated system, your examples of your insulated systems are, one is your that we will use your universe. Universe is my isolated system. You have to remember this, because we will know that what is the composition of universe. Universe comprises your system and surrounding. The external to the system is surrounding. So if we will talk about the whole thing which we will see, the universe, there would be no mass transfer against in the universe, and there would be no energy transfer takes place in the universe. So this is the case of your isolated system. Next example is your isolated, or you can say that insulated bottles, in which we will use our thermal bottles, in which we will fill some warm water or something. So this is known as your isolated system. So isolated system, if I will precisely say, is a special case of closed system, in which there is no energy transfer takes place. No energy transfer takes place. Remember, we know that in closed system there would be no mass transfer, and if in that closed system there would be no energy transfer, it will behave as an isolated system. So isolated system is that system in which there is no energy transfer that can be taken place, and also no mass transfer is taking place. This is a case of your isolated system. Next topic, if we will talk about, is your thermodynamic equilibrium. Next important topic is known as thermodynamic equilibrium. Thermodynamic, it's not a thermal equilibrium, it's a thermodynamic equilibrium. So what is the meaning of your thermodynamic equilibrium? We will say that a system is we will take everything on with respect to system, because my whole concentration depends on this part, that is a system. A system is said to be in your thermodynamic equilibrium if it is in, there are some cases, if it is in, number one, if it is in, first one is your thermal equilibrium. If it is in thermal equilibrium means equality of temperature. What it means, equality of temperature? Thermal equilibrium means the temperature of the system and that of surrounding would be same. There would be no temperature gradient present in the system and also with the surrounding. Please remember, equality of temperature or thermal equilibrium, if I have to explain it here only in a very short, if I have to explain what is the meaning of your thermal equilibrium, see what is the meaning of thermal equilibrium. Let us take this example. This is a system, any closed system if I am taking about. Suppose in this system the temperature is your 50 degrees Celsius. There would be no temperature gradient inside the system, which means at any point in the system, at any point, you take any point in the system, that at every point the temperature would be 50 degrees Celsius, which means there would be no temperature gradient inside the system, and also this external to this system is behave as my surrounding, and we know that the T infinity, the surrounding temperature is represented by T infinity. T infinity should also be 50 degrees Celsius, so that there would be no heat transfer, or if I precisely say, there would be no temperature gradient with in the surrounding and in the system. No temperature gradient. Temperature gradient means the difference in temperature. As we know that if there would be a temperature gradient present, the heat will transfer. So there would be no temperature gradient inside the system, and also no temperature gradient between system and surrounding. Then only we can say that your system is in thermal equilibrium. So for thermal equilibrium, equality of temperature holds good. Second your condition for your thermodynamic equilibrium is, second condition would be my mechanical equilibrium. Second would be my mechanical equilibrium. Mechanical equilibrium is, we will if say that this is your equality of forces or your pressures. Equality of forces or your pressures. What is the meaning of equality of forces or equality of pressure? We will say here one thing, please note that equality of pressure means the pressure should be uniform Note that this pressure should be uniform throughout the system. Throughout the system. And there would be no pressure gradient present. There would be no pressure gradient present inside the system. The pressure should be uniform throughout the system and there should be no pressure gradient, because we know that if there would be any pressure gradient present, the net force occurs on the system, so that system would never be in mechanical equilibrium. Here, if I am talking about mechanical equilibrium, this pressure can change with time. Can change with time. It means it will have unsteady process, unsteady state, but it will be uniform throughout the system. What is the meaning of this line? It can change with the surrounding, with the time. Suppose this is a system. If I am talking about one system, is this one. When I study this system at time t is equal to 1 second, if I am taking about t is equal to 1 second, at t is equal to 1 second, your pressure inside the system is equal to 1 bar, which means at any point in this system, the pressure would be 1 bar. And if this time changes, if I am saying that, if this time changes, suppose this whole system, if I am studying t is equal to 5 second, if in this time the pressure will equal to 5 bar, but it will remain 5 bar throughout the system, means at one instant the pressure should remain uniform throughout the system. It will change with time. It can change with time, but it will remain uniform throughout the system at that one instant. It means pressure should be uniform but unsteady. It can change or it may not change. It will depend upon the process. So second one is your mechanical equilibrium. The third condition for your thermal equilibrium is, the third condition is your chemical equilibrium. Third condition is my chemical equilibrium. What is the meaning of chemical equilibrium? Chemical equilibrium means there would be equality of chemical potential. There would be equality of chemical potential. Chemical equilibrium means in the system no chemical reaction should occur. No chemical reaction should occur. No chemical reaction should occur inside the system. That means all of them behaving as an inert type of system. So chemical equilibrium means equality of chemical potential. And fourth one condition is your phase equilibrium. Phase equilibrium means for a thermodynamic equilibrium in the system there would be no change in phase occurs. There would be no change in your phase occurs. Phase change will not occur, which means that there is no conversion of solid to liquid or liquid to solid, solid to vapor or vapor to solid. Phase change will not occur. Then only we can say that this system is in thermodynamic equilibrium. It means for your thermodynamic equilibrium, the first condition is your thermal equilibrium, second condition is my mechanical equilibrium, third condition is my chemical equilibrium, and fourth condition is my phase equilibrium. Then only we can say that the system is in your thermodynamic equilibrium. The next topic in this lecture is, the next topic is what is a pure substance. What is a pure substance? We will discuss pure substance later also, but here only I am discussing the definition of pure substance, the meaning of pure substance only. I will discuss the various conditions of pure substance, various phase diagrams of pure substance in our later chapters, but here I will introduce only the definition of pure substance for the time being, for your understanding of pure substance. A substance is known as pure substance if it is homogeneous, in chemical composition throughout. If it is a pure substance, is that substance if it is homogeneous in chemical composition throughout. Chemical composition throughout means if I would take any sample from that system, if I will select any sample of that system, it will have same composition throughout. Which means if I am talking, this is my one substance, a system. If I am talking in this jar, if I will fill any material, suppose if I am filling in this some gas, suppose A gas. So if I would take any sample of that gas from this system, if I would take any sample of this gas from this system, suppose I am taking this sample from here, a sample from here, a sample from here, and one sample from here. If I would take 5 samples from this system, that all of them have same chemical composition throughout, then only we can say that this is behaving like a pure substance. All of them have, all of the above samples, should have same chemical composition, If I am talking about the examples of this, if we will take some example of pure substance, suppose this is a beaker, here I fill some water in this. This is water. If I will fill some water in this, and here some steam is present. Steam is also a composition of water, because steam is another phase of your water, which is in gaseous phase. So if I fill some water here and a steam, and in this case if I would take 3 samples, one from this steam, one from this water, and one from this both interface, from this interface, from some from water and some from steam. So if I take, this is my sample number 1, this is my sample number 2, and this is my sample number 3, I would say that all of them have same composition. One, your sample 2 and sample 3 have only water, the phase may be different. Here the water is present in your gaseous phase, here it is in liquid phase, but here it is partially liquid, partially gas, but your composition is same. Phase may be different. For your pure substance, phase may be different, but composition with same. So this is a pure substance. This is a case of your pure substance. This is a case of my pure substance. If I will talk about another example, that is, if here I took one beaker, and this is a partition here. Partition means one interface is there. Below here, this is some water. Here some water is present, and here some oil is present. some water and above some oil is present. If in from this again I will take three samples, sample number 1 from this part, sample number 2 from this interface, and sample number 3 from here. If I will talk about here, in sample number 1 only oil is present, in sample number 2 partially oil partially water is present, in sample number 3 only water is present. So your sample 1, 2 and 3 have different composition, which implies that it is not a pure substance. It is not a pure substance. So for pure substance, the system must be homogeneously of same composition. Composition must be same throughout the system, or the homogeneous mixture is known as your pure substance. Now, if I'm going ahead, the next topic is my properties of system. Next basic topic introduction part is your properties of a system. What is the meaning of properties of a system? Properties of a system. Properties of a system are characteristics of a system. Properties are characteristics of a system. Means these are those characteristics by which I am going to define my system. I have to define a system. So my system would be defined with the help of some properties like your pressure, temperature, volume, mass, your entropy, your internal energy, enthalpy. All these are the characteristics of a system with the help of which I will say that in this system the pressure is so much, temperature is so much. So these are the characteristics of a system. So properties are the characteristics of a system. If I will talk about the example of properties of a system, so examples are your pressure, volume, internal energy. We will talk about what is the meaning of internal energy. I am just writing here. Internal energy, enthalpy, entropy, and so on. There are n number of characteristics of your property of your system. So I am writing only pressure, volume, internal energy, enthalpy and entropy. There are n number of characteristics of your properties of a system. Now the next most important topic is your types of properties. Types of properties. What is the meaning of types of properties? There are two kinds of properties. First one is your intensive properties. First one is my intensive properties and second one is my extensive properties. Properties are of two types. One is your intensive property and second one is your extensive property. We will take first that intensive property. I will take first which is intensive property. Intensive property. As we know that properties are the characteristics of a system. So these characteristics are of two types. One is our intensive property and one is your extensive property. So intensive properties are those properties. Intensive properties are those properties or those characteristics which are independent of mass. Which are independent of mass. Intensive properties are those properties which will not depend upon the mass of the system. That properties which will not depend upon the mass of the system is known as your intensive property, which means if I decrease or increase the mass of a system, the value of that property shall remain same, which is earlier, then that property is known as your intensive property. So if you have to learn, so I is for intensive and I is for your independent. So intensive properties are those properties which are independent of mass. If we will take some example of your intensive property, the example of your intensive properties are your temperature, our density, thermal conductivity, viscosity. This will not depend upon the temperature of the mass, and pressure also. Pressure, temperature, density, thermal conductivity, viscosity, etc. are intensive properties which will not depend upon the mass of the system. What is the meaning of this line, the independent of mass of a system? It means if I am going to decrease the mass of a system, suppose there is a system which is having some mass, say 1 kg. If I am going to decrease, if I am going to compress that system, and by any means I compress that system to a point, at any means I compress that system to a point, so I know that at a point have no mass, no volume and no area. Point have no mass and no volume. That means at that point mass of that system is 0. If at that condition also, when the system is having no mass, at that condition also, if some properties are defined, then those properties are known as your intensive properties. Intensive properties are those properties which are still defined when you make a mass 0 of a system. That means intensive properties are defined at a point. This is the most important conclusion. You have to note that the intensive properties are defined at a point. Only intensive properties are defined at a point. Only intensive, we can define in only intensive properties at a point, because we know that intensive properties are independent of mass, and at a point mass is 0. So at a point only intensive properties are defined. You have to note this. And if I will take now some good examples, that one is your stress. In strength of material, you will study about the stress. If precisely I am talking about the definition of stress, so I will say that stress is the defined at a point. Stress is always and always defined at a point. Your stress is always defined at a point. In strength of material, you will study this. I am only recapitulate your concept. Stress is defined at a point, and if something is defined at a point, then that means it is an intensive property. So stress in your strength of material is your intensive property. This is the concept of your intensive property. Please, you have to note that. Next type is your second one is extensive property. Extensive property. What is the meaning of extensive properties? Extensive properties are, as we know, intensive properties are independent of mass. So extensive properties are those properties are those properties which will depend on the mass of the system. Which will depend on the mass of the system. Means if I am going to increase or decrease the mass of a system, that these value of these properties, those extensive properties will change. So it will depend on the mass of the system. Those properties which will depend upon the mass of the system are known as extensive property. So extensive property changes when you are going to change the mass of a system. If I am talking about some examples of your extensive property, the examples are your volume, internal energy, your enthalpy, entropy. These all are your extensive properties. Volume, internal energy, enthalpy, entropy. These all kinds are your extensive property. So please note that in this case I make a statement which is most important for your objective point of view. You may find one question here that if I am writing this in your note that ratio of two extensive properties is an intensive property. Ratio of two extensive properties is an intensive property. Means if we take ratio of two extensive property, suppose we will take the ratio of internal energy per unit volume, enthalpy per unit volume, entropy per unit volume, that property is an intensive property. You have to remember this thing. The ratio of two extensive properties is an intensive properties, and there is a term which I am introducing here, specific properties. What is the meaning of specific properties? Specific properties are extensive property per unit mass. Any extensive property per unit mass is known as your specific properties. Specific properties are those extensive property per unit mass, and if we divide some extensive property with mass, then that would make some intensive property. So specific properties are intensive properties. Specific properties are intensive properties. That means extensive property per unit mass makes you a intensive property. If I will take about the example of this intensive property, the specific volume, if I am going to write some example of specific properties which will become intensive properties, are your specific volume, specific internal energy. We will go through all these terms in our thermodynamics syllabus. Specific internal energy, specific enthalpy, all these are your intensive properties. Specific enthalpy, specific entropy, and so on. Specific properties which are extensive property per unit mass should behave as an intensive property. So this is a type of properties. One is your extensive property and another one is your intensive property. Now, how to find whether a property is an intensive or extensive property? So, how to remember the type of properties? How you will remember the type of properties, whether the property is your extensive or intensive. The easy way to define those properties are, suppose you will take one system. You will take one system here. This is my one system. It will have, earlier it will have some mass m, pressure P, volume V, internal energy U, enthalpy H, entropy S, density rho. These are m is mass, P is pressure, V is volume, U is internal energy, H is enthalpy, S is your entropy, rho is density, and T is your temperature of this system initially. Initially, this is the properties of system. If I am going to divide this system into two compartments, the same system, I am taking the same system and divide this system in two compartments equal two compartment. That means this system now have mass m by 2 and now have mass m by 2. If I would talk about those properties which will not change because of this, see, the mass, you will change the mass of the system. Initially the mass is m, now the mass is m by 2, and those properties which will not change because of this mass change are known as intensive property. If I would say the temperature would not change, because if here the temperature is 50 degrees Celsius, the temperature would remain same. Pressure would not change, your density would not change, because density would not change, because if mass is halved, so volume is halved, density is mass per unit volume, so that mass per unit volume will remain same. So the temperature, pressure and density will not change because of this mass change. So these red color properties are known as your intensive properties. If we are talking about the properties which will change because of this mass, I would say that your volume will become V by 2 and V by 2. Both volume will change. So volume is mass dependent. Your internal energy will change, U by 2. Enthalpy will change. Your entropy will change. These properties will change. Your volume, internal energy, enthalpy and entropy, all of them will change. So these blue color properties are known as your these blue color properties are extensive properties, and red color properties are your intensive properties. Next is the most important topic, if I am talking about, is important points with respect to properties. Next most important thing is important points with respect to properties. Important points with respect to properties. What are the various conditions, various points which are valid for your property? The first one, the most important is, the first most important thing is, properties are point function. Properties are point function, not a path function. Properties are point function, not a path function. What is the meaning of this? The property of a system is depending upon the final point at which your system would reach. It will not depend how you will reach for that point. Suppose if I am talking about this condition, if I am explaining this with the help of one graph, let us say this is some graph, let us say some PV graph or some any coordinate axis. Let us say this is PV graph, pressure volume graph. So if I would say that I wish to go from this point 1 to this point 2. I want to go this point 1 to point 2. This is my initial point. This is my initial point. and this would be my final point. I want to go from this point 1 to point 2. At this point 1, when the system is in equilibrium, it will have some characteristics, some property. Suppose this is, it will have some pressure P1, it will have some volume V1, it will have some temperature say T1, internal energy, enthalpy, and so on. If I have to go from this point 1 to point 2 means it will have some pressure. This is P2. Let us say this is P1. This is some pressure P2. And here the volume is your V1. And at point 2 the volume is, let us say this is V2. We have to change the properties of substance or characteristic of your system. And from this point 1 and point 2 I have n number of ways to go. Suppose I would go from 1 to 2 through your process A, and also I would go from point 1 to 2 through your process B. Both the process are different. Process A is another followed some other path. Process B follows some other path, but the properties of system, that is properties at this point 2 and properties at this point 1, will not depend upon this path followed by the system. Properties are your point function. Point function means it will only depend upon the initial and final state. Means if I would write here, what is the meaning of this point function? Point function means it will only depends upon initial and final state, or precisely I would say it will depend upon your equilibrium position only. Equilibrium position only. It will not a path function. It will not depend what path you are going to follow while during this experiment. It will only a point function. Second one is, the most important points with respect to your properties which we have to run is, second point is properties are independent of past history. Properties are independent of past history. What is the meaning of this line, that properties are independent of past history? Suppose in this graph, if I would take that there are two equilibrium position, one is that this point 2, one is this point 1. Properties of system at this point 2 will not depend upon your past history, that is your point 1. Properties at point 2 is not depend upon the properties at point 1. We will take this system from point 1 to point 2, but the properties of this point 2 will never ever depend upon the properties of this point 1. They are independent of your past history. This is a unique point and this is one unique point. These two will never depend upon their past history. You will follow any process, any path you can follow, and its past would be, if anything, it will never ever depend upon its past history. Second and third most important point is properties are exact differentials. Properties are your exact differential. What is the meaning of this exact differential? Exact differential means, if I would say there is some property, let us say there is some property A. I am considering A as any property. Exact differential means if I would integrate this dA, this property from process 1 to 2, from point 1 to 2, it would be equal to A2 minus A1. This is the meaning of exact differential. That means the change of property from point 1 and point 2. Please listen carefully. Change of property from point 1 to point 2 depends only on the final point and initial point. It will not depend upon the path followed, and this is known as your exact differential, that the integration of property from point 1 to point 2 will give you the value A2 minus A1. This is known as your exact differential. So properties are exact differential. This is the most important unique condition of your properties. These are your exact differential. We will take this lecture again on continuation. Thank you.